What is the final volume of a gas originally at 30.0 liters, 250.0 torr, and 25 degrees Celsius if its pressure and temperature are changed to 500.0 torr and 115 degrees Celsius? We can solve this problem using the ideal gas equation PV equals nRT. Since this problem deals with a change involving an ideal gas, let's refer to the conditions before the change occurred as P1, T1, and V1. We can see that all of these are given in the problem. The initial pressure, P1, is 250 torr. The initial temperature, T1, is 25 degrees Celsius, which we must convert to Kelvin when we're doing calculations involving gases. The initial temperature is 298 Kelvin. The initial volume, V1, is 30.0 liters. Therefore, we have enough information to solve for the number of volumes of gas in our sample. It's equal to P1 times V1 divided by R times T1. After the change has occurred, we assume we have the same number of moles of gas, unless we are given information to the contrary. We make this assumption. The problem gives us the final pressure and temperature, and we're being asked for the final volume. The final pressure, P2, is 500.0 torr. The final temperature, T2, is 115 degrees Celsius, or 388 Kelvin. After having solved for the number of moles of gas, we now have enough information to solve for the final volume. The final volume, V2, is equal to N times R times T2 divided by P2. An alternative is to use the so-called combined gas law. Since we're dealing with a fixed amount of gas, the combined gas law says that P1 times V1 over T1 equals P2 times V2 over T2. In fact, according to the ideal gas equation, both sides of this equation are equal to N times R. We can rearrange this equation to solve for V2. Essentially, this formula says that to get the final volume, we multiply the original volume by the ratio of the initial pressure to the final pressure, and by the ratio of the final temperature to the initial temperature. Plugging in the values from the problem, we find that the final volume is 19.5 liters. The correct answer is A. Let's see if our calculations make sense. The pressure increased from 250.0 torr to 500.0 torr. Therefore, we would expect this change in pressure to cause the volume to decrease. We can see in our calculation that we are multiplying the initial volume by a pressure ratio that is less than 1. 250 divided by 500 is a number less than 1. Multiplying something by a number less than 1 gives us a smaller number. As for the temperature, it increased from 25 degrees Celsius, or 298 Kelvin, to 115 degrees Celsius, or 388 Kelvin. An increase in temperature should lead to an increase in volume. We can see that in our calculation, we are multiplying by a temperature ratio that is larger than 1. 388 divided by 298 is larger than 1. Multiplying something by a number larger than 1 gives us a larger number. A final note. Had the pressure decreased, we would have plugged in a pressure ratio that is larger than 1. And had the temperature decreased, we would have plugged in a temperature ratio that is less than 1.